So we will see the implementation of single linked list. We are doing this using C++ language. So this is normal. I have to write using namespace std, because I need not use std always, right. Now I have to create a structure. If you remember, we are following a structure template, self-referential structure. So I will create the structure. Struct, I will give some name node. Then I have to create how many variables? Int data, and I have to create a pointer which is pointing to the same structure. So struct node star next, right. So this is the definition of the structure, right. Once you when you want to insert new element, you can keep inserting you can keep creating the variables for this struct. Okay. Next, struct node. I hope this is clear. We are creating a variable int data, we are creating a pointer variable which will point to the which data type? Point to the structure node data type, user defined data type. Okay. Next, I will try to I can write main. We can start writing main also. This is possible, we can do that, but we do not know what to do with this. So I will try to write to how to create a new element at the beginning. Okay, let us see how do we write that function and then call it from main. I will leave this empty now, because we have to write a code to inserting a new element at the beginning. For that, we will try to write the code. Okay, so I will write a function void insert at begin. Some name you can give, our choice. So maybe I can give here the int data. I want to pass the new data as the why am I taking here data? Because that is the element I want to add at the beginning. So that data I am taking. Now I will try to create a memory location. How to create a memory location for a structure? Struct, right, node star, let it be called as new node. Let it be called as new node. Okay. Using malloc statement, I will try to allocate memory for that particular node. So what is the syntax of that? You should have the type, what type of data it is going to store, and how much memory I have to allocate. Both I have to give. So both will be of type this only, struct node only. Okay. Struct node will be the data type, and then malloc function, and then how much memory should I allocate? How much memory is required for each node? That much I have to allocate. So again I will be using here struct node. Okay. How much memory is required? Oh, sorry, something has gone wrong. Let us write it, struct node, right. So this is my statement. One point is missing, malloc function is not available in this header file. So let us include the header file std, sorry. So this header file is available in stdlib.h, malloc function. Once this is done, new node is done, what I have to do? I have to assign data, whatever data is being called here, that I have to assign to new node, right. So we will write new nodes data equal to, maybe I will just change this to some other variable x, let us call it x. So I am giving x. Then new node, what I have to do here? The next new nodes next should be null. New nodes next should be null. Why? These three are default statements, right? This statement is to reserve memory, this is to assign the value to that new node, and this is to assign null to the address part of the new node. These three commands are done. After this I have to make assuming there is no element in the list. Assume there is no element in the list. Then what I have to do? I have to write head equal to new node. Assuming there is no element in the list, I have to write it like this, head equal to new node. Or maybe if I am doing it for the beginning, I will write new nodes next equal to head. This command will try to insert an element at the beginning. New nodes next is equal to head means we are inserting an element at the beginning. Then I am making the new node as head. Okay. So this is your function. inserting at the beginning, right. Now in main I can call this function insert at begin. In main we can call this function insert at begin. With what value we have to pass it here? Maybe I want to insert 10. I want to insert 10 value. Okay, but how will I know? I have to display, right? This is happening, but I have to display and see how many elements are there in the list. For that, this is default again, return 0, a default statement. Now I have to write a function for display. I should see that the 10 is available in the list, right? So for that, I will write another function, void display. I don't need anything for this input. What I have to do in this void display function, I have to keep printing the elements until I encounter null, right? Display is like traversing the list. I am asking it to display the list. How many elements are there in the list? How do I know that? I know the beginning is at head and the end is at the last node will have null. So I have to traverse the list. What is the logic of traversing? Let us first create a temporary variable. Struct node star temp. Let's create a temporary variable. Once you create this struct node star temp, then we can what I have to do here, temp should also point to head. Why am I writing this temp equal to head? Because head I am not going to change, but I am going to point the head node as the temp node. Both should point to the same location. Now you write your while loop. We need our while loop, right, to traverse the list. What is the condition here? While temp next is not equal to null. When temp next is not equal to null, what you have to do here? You have to print, right? So I will write cout this temp data. Okay, see here, why is this while condition required? This while will iterate over the elements of the list till it reaches end. Until it is not null, it will keep printing temps data. It will keep printing temps data. After printing this, what I have to do? I have to move forward, right? One time, okay, next time again I have to update this temp equal to temp of next. So this will help me in displaying the values of the list. I hope you understood this display function. It is same as your traverse function. Let us go and see the traverse function. Yeah, traverse code. If you see here, traverse code, see, I am creating a temporary variable which is pointing to head. Then I am iterating till it is not null. I am printing the data, temp of data, I am printing it. Same thing I am trying to do here. I am iterating, you can use while loop or for loop. I am iterating till it is not null. I am always printing temps data, and then I am moving to temp of next. If it is null, stop there, right? So I wrote a display function here. So after inserting a new element, I will call the function display. I will call the function display. Okay. So it is highly encouraged that we write these functions above main. Okay. We have to write this above main, because why am I writing this above main here? When compiler will do the compile part, it will, if it sees this insert at begin, it has to jump here and see. It has to jump here and see. I hope this program is clear. Any doubts in this till now? How I wrote this logic? It is same as what we were discussing in the algorithm, right? Yes, is it clear, students? Okay, see, this is default header files. For C++, IO stream is required, and stdlib, because malloc function is a dynamic memory allocation technique, it is available in stdlib. I am using namespace std default one to avoid using std always. Then I have created a structure here, struct node. Okay, let me just once compile and see. It's asking sl insert at begin. Some mistake here. Head was not declared in the scope. Yeah, head is not here. So we have to write head. We can write it in main or also here. In main we can write that struct node star head. It means I am trying to create a variable. I am trying to create a variable node. head was not declared in this scope. Okay, we have to pass here the head variable also. So struct node star head. Two variables I have to pass. So in main here I will give here, I will be passing ampersand head comma 10. Now let us see if this executes. Again head. Okay, in display also I have to do the same thing, because I have to give the head location, right, always. So here also I have to receive this. Cannot convert node star at the beginning. Right. It has to display the element which we are inserting. Maybe some function mistake here. Insert at begin struct node. Let me write this outside. Struct node, I can write it here anywhere and assign null. Insert at begin struct node head and in text. I am declaring it as global so that I do not pass it here. Yeah, so we got empty, at least this is executing. Let's try to analyze this. So I am creating a node, then I am creating a pointer that is head. I am trying to insert at beginning by passing a value here, right. So struct node new node equal to struct node star, that is the data type, malloc and size of struct node. This new data I am assigning with the new value, and this I am assigning to null, and new node equal to new node next equal to head, then head equal to new node. This is just to make that as the head. And in display I am creating a temporary one, I am assigning that to head, temp next not equal to null, keep printing. So this is not working here, temp of data, this is not printing, it is happening insert. Let us see here, see out the elements in the list are, maybe here also if I write see out, yeah, it is executing, but the insert operation is not happening because it is coming here. Let us see, struct node star temp, temp equal to head. If there was no element, if there is, for now there is no element, right. So I am creating this, I am allocating x value, I am giving the temp new node next equal to null and the new node next equal to head. I think this is not required because head is null, I have to make this as head. Head is equal to new node. Let us comment this and see. Okay. Insert at begin, the elements in the list, display is normal, it is not returning anything, void display. I have to print temp of data, that is it, temp equal to temp next. Struct node, at least insertion is happening successfully. Yeah, insertion is success. So we are it is executing these three statements. If I write here see out, the inserted element is, I can write a new node of data. Let us do this. See, the inserted element is 10. So this is fine. We are able to insert the element into this happily. But when I am trying to print it, some query. Okay. when I am trying to display cout execution check, this is also coming, it is temp equal to head, while temp next not equal to null. If I do this, temp not equal to null, yeah, now we are getting the answer. The condition was wrong. So, let us remove this. Right. So, see this, I think I will just maximize this. Font. I hope it is visible. The elements in the list are 10. Can you see this? Elements in the list are 10. Right? Is it clear? Did you understand this, how I wrote it? Once again, I will quickly summarize what we have seen. Then we will come to a, we will do it more. Okay. See, I have attached the header files like we do in C++. I have created a structure here. After creating a structure, I have assigned the head value as null initially. Then we wrote a logic to insert a new element at the beginning. Okay, to insert a new element at the beginning by passing x value, one element as the input. Then again, I am creating, this statement is to allocate memory for the new node. This is to assign the element to the linked list, and this is to assign the new node to the null. Then new node next equal to head and head equal to new node. These two statements will add the new element at the beginning, because the function name is insert at begin. Then I have wrote a display function. This is just to display the elements of the list, what all elements are there. In main, I am calling the function insert at begin with 10. I am displaying it. Let us write this once again and see if the second element is being added at the beginning or not. So, let me add now 20. Okay, let us add this 20 now. Now, let us see if the list becomes 20, 10, because with this 10, 10 will be added. With 20, what is this function here? Insert at begin, right? So, 20, 10, the list should become 20, 10. So, here I will give the end line so that we get the output in separate line. If I execute this, see, the elements in the list are 20, 10. I hope you can see here, the element in the list are 20, 10. So, it is adding. If you add more, if you repeat this again and again, you will get elements at different locations, 30 and 40. So, the elements in the list are here, also I will put endl. Why endl? Because to print the output in next line. See, now I am adding 4 elements. So, the list should become 40, 30, 20, 10, because I am inserting at the beginning. I am inserting at the beginning, right. So, this is the logic. These 3 lines are fixed to create a new node and insert some value into that. Okay. So, let us execute and see. See, the elements in the list are 40, 30, 20, 10. Okay. So, we are able to insert the element in the list. Now, let us slowly extend this to insert an element at the end. Let us write another function to insert an element at the end. So, mostly I will copy paste this code and we will make changes to that. So, insert an element at the end. Now, what you need, this line is fixed to create a new node. This is to create assign the value. Okay, let us write this take as y, because in a single program to avoid any errors. So, new node data equal to y, new node next equal to this. This way I am inserting. Now, what is the logic of inserting? This is fine. These 3 lines will create a memory block, reserve a memory block for me, and it will insert, it will allocate the value y in the data part and assign null. Now, what I have to do? I have to iterate over the entire list. So, we have to write while condition. What is the condition here? That we have to take a temporary variable, right? We have to take a temporary variable. Let us take the temporary variable here. Struct node star temp. I have taken a temporary variable. So, where should this temp point to? temp should point to head, temp should point to head. Okay. Now while temp not equal to null, while temp not equal to null, I have to iterate over the entire list. I have to, same logic like we are doing for printing here. No, I have to iterate over the entire list. So I will write temp equal to temp of next. So what will these two lines will do? This will bring me to the last node. Bring it to me last node. Now if you want, we can write open and close like this and put it here. So with this command will iterate over the entire list and reach the end of the list. After reaching end, now what I have to do? You already have a new node. Just make temp next to new node. Just assign temp. Why? Temp is pointing to the last node of the linked list. That's next, which is null, make it to new node. Make it to new node. That's it. With this we will add the new node in the list. This two is not required. Now let us try to see whether this insert at end works or not. Okay. So I will delete this. Let us write insert at end with 20. Okay. So insert at begin is actually inserting only one element, that is 10. Then after 10, 20 should come. Okay. Let us compile this. Some mistake here. Insert, did I write it? Main. This is fine. Insert at begin, open, close. Then insert at end. Again open here and close. Yeah, this is okay. And the problem here. Some check. We are inserting a new element y. I am creating a temporary pointer temp that I am assigning to head. Then I am creating a new node. Let us see whether the data is assigned or not. New element at end, that is new node data. Let us see whether it is inserting an element or not. Yeah, new element inserted at end, that is 20. So this is executing. New element inserted at end, that is 20. Okay. Now this temp null, it is iterating and attaching it to the new node. Then which function is not working? Insert node elements in the list. Let us compile and see again. This is working. Okay. This function is working. Display is not coming after this insert at end. Let me write another statement here. This is true, right? Temp of next equal to new node. This is just to iterate, while temp next not equal to null. While temp next not equal to null, temp equal to temp next. Let me do this. Yeah, see the new element, we got this. This I will comment it. Yes, so we have added a function now, insert at the end. I am giving value y as the input. This is just to create a temporary variable. To traverse, I need a temporary variable. I am assigning it to head because I have to begin from the head. These three commands will help me to create a node and assign some value. Then using this while loop, I am trying to iterate over the list. Once I reach the end, I am just assigning that to the new node. So with this it is linking. You see here, insert at begin is inserting 10. Then insert at end 20. I will repeat once again this. Let us see we are getting 10, 20, 30 or not. 30. Okay. Let us see the output. See, the elements in the list are 10, 20, 30. So we are able to add the elements at the end. Now again I will give at the beginning. Let us see this. Let us make a change. Let me put here 40. So what will happen here? First 10 will be created. Then for that 20 will be attached. List becomes 10, 20. Then inserting at again end again. So list becomes 10, 20, 30. Then I am inserting an element at the beginning, that is 40. So list should become 40, 10, 20, 30. Let us execute this. See, 40, 10, 20, 30. The list has become 40, 10, 20, 30. So with this insert at the end is also working. Next what I have to do, what is the next function which we have studied, that is inserting an element at any given position. Inserting an element at any given position. Let us again add one more function for that. Any doubts till now? Any doubts here, students? Any doubts till now? Is this clear? Okay. So let's create another function, inserting an element at any given location, right? Void insert, same thing I am trying to write, insert at position, and I have to give the value, let that be z, I want to insert at position. So in the function we know these three things are common. These three things are common because I have to create a node and allocate the value to z and make it null. These three statements are common, and I also need a temporary variable to traverse till that position. To traverse till that position, I need a temporary variable that I have created as temp. We are taking one more variable k equal to 0 because I have to stop one step before, right? We have to stop one step before the position. If the okay, we have to give the position also here. We have to give the position also here, int p. Okay, because which location you want to add. If the position is 3, you have to stop your iteration till 2. So this, after this I will write my while loop to traverse the list. How to write? Until k less than p. Until k less than p. Okay, what I have to do here? Until k less than p, keep moving forward, that is temp equal to temp next. So k is 0, position is given as 3, so 0 less than 3, move forward, it moves to second one. Then k plus plus, then I have to do k plus plus. So k will become 1, 1 less than 3, yes, move forward. For third position we have to take like this, k1. Okay, so this will reach which position? It will reach the second position. After reaching the second position, what is the logic I should do here? How do I insert an element here? What I have to do here? Temp, where is temp pointing to? Position 2. I have to take new nodes next, point it to temp next. Sorry. New node next point to temp next. Next, temp next point to new node. Okay, temp next point to new node. That's it. With this we can insert the element. Let us try to execute this and see whether it is working or not. Inserting an element at any given position. So I will just again make it short, so that we will write another function, insert at position, and I am giving the value as 30 and the position as 2. I want to insert the element at second position. Let us see with this work. So at the end our answer should be 10, 30, 20, because list contains 10, 20. I am inserting 30 in between. So let us see whether this works. See, oh no, it has come, 30 has come to the end. Maybe it is taking this way. Yeah, see here. So this should be 0. This should be 0, and this is the position which I want to insert. No, so this is 1 now. Yeah, so position which I want to insert is 1. What is this 1? This 1 indicates where you want to add the element. After 1, this indicates I want to insert the element after 1. That's why this logic is working like this. So see, 10, 30, 20. Let me add one more inserted position and see whether it is inserting after position 2 or not. Let the element be 40. See, 10, 30, 40, 20. After second position I am able to add 40 there. right. So with this we complete the implementation of single linked list, inserting at element at the beginning, at the end, at any given position. Okay. If we go through the code once again, first I have to create a structure, then I have to write a function for inserting at the beginning, inserting at the end, and then inserting at any given location. Then I have one function display to print the list. Display is very simple, you have to traverse over the list and keep printing the element until you reach the end of the list. In the main, I am trying to go through this, call these functions with the values, and it is giving me the list. Okay. So this is the implementation of single linked list in C++.